What's up, everybody? Mr. Kozad back with another video lesson. Today's topic is on all about vertex form with quadratic functions. This lesson, we are going to talk about the attributes of the graphs of quadratic functions when they're given in vertex form, things like the vertex, the axis of symmetry, the y-intercept, and kind of how to derive those things from an equation in vertex form. So here we go. This is the most basic kind of form of vertex form that you're going to see. There are some times that you may see, I'll write this for you, something formatted like this. Okay, they add one transformation here that's not listed. Okay, there might be some times where you see it like this. For our conversation today, I'm going to kind of ignore this b value, but just know that it is possible for there to be a b value there. We'll talk about that at another time, but for today, we're just going to look at what happens when we have a form like this, okay? It's called vertex form for a really good reason, okay? It might be self-explanatory, but it's called vertex form because you can actually identify the vertex from looking at the equation, okay? So we know that our vertex is we're going to use the h value and the k value. So my vertex there is hk. Remember when we talked about transformations, the h value is going to shift the graph left to right. The k value is going to shift the graph up and down, okay? Now, the axis of symmetry, you kind of have to think back to geometry a little bit, and I know that that gives some of you PTSD because your geometry experience wasn't great. Okay, but if you think about a parabola here, okay, and we think about symmetry. Symmetry is a line that cuts something in two equal halves, okay? So if I look at this parabola that I have sketched up here, if I drew a horizontal line, that cuts the parabola in half, but not equal halves. So very clearly you'll see that the axis of symmetry is going to be a vertical line that passes directly through the vertex, okay? So imagine that dashed line is my axis of symmetry, and it's going to cut this parabola into two equal pieces. Well, you also have to remember how to write the equation of a vertical line. The way you write an equation of a vertical line is x equals, and it passes specifically through the x value of the vertex. So the axis of symmetry is going to be x equals h. It will match the x value in the vertex. Okay, those will always match. Now for the y-intercept, you have to kind of remember what a y-intercept means. Okay, a y-intercept is when we make a 0 for x, and then we plug in and see what we have left over. Now, to find that, you're going to take function f, and you're going to plug 0 in for x. I would say that probably the most common misconception here on the y-intercept, the most common wrong answer that I see, is people think that it's 0k. It just feels like when you look at it that the y-intercept would be 0k. That's not true. That's not the case. You actually have to plug in 0 into the function and see what you get out. Okay, so let's actually try this in the context of a problem. Okay, so here's example 1. It says, sketch a graph of the function, find the coordinates of the vertex, the axis of symmetry, the y-intercept, the domain, and the range. And here's our function. Okay. So in vertex form, let's obviously start with the vertex. So to find the vertex, we're going to pull out the h and the k value. Now think to yourself, what does this minus 3 do to the graph? Okay, it's going to shift everything to the right by 3. And this plus 2 out here is going to shift everything up 2. So my vertex is going to be at 3, 2. Now, if you're brand new to this, you might be really confused because you might be seeing minus 3 and think, well, shouldn't that be to the left 3? No, it's not. Okay, for the h value, you do not trust the sign. You always go opposite from what you would think. So when you see minus 3, that's really shifting to the right by 3. Okay, well, if my vertex is at 3, 2, my axis of symmetry should be easy. That's just going to be x equals 3. Okay. All right, so now the next thing I'm going to do is my y-intercept. Okay, my y-intercept. Now I know the x value will be 0, but I have to actually go through and calculate to find what y is. So we're going to calculate f of 0. So I take that function and I plug a 0 in for x and solve. So we've got 0 minus 3 is negative 3. Negative 3 squared is 9. So negative 2 times 9 is negative 18. Negative 18 plus 2 is negative 16. So my y-intercept is at 0, negative 16. Okay? So now from here, I'm actually going to draw a sketch of the graph. Okay, it's not going to be a huge sketch, just a small little sketch here so we can see what's happening. My axis of symmetry is what I start with. It's over here at like x equals 3. The vertex is at 3, 2, somewhere over here. And the y-intercept is going to be way down here somewhere, like 0, negative 16. So very clearly you can see that this parabola is going to open down, and make sure that you draw two symmetrical halves. Okay. One way that you can check for symmetry is that point that you graph the y-intercept. If you reflect that over the axis of symmetry, they should be equidistant. Okay, that's how you can kind of test for symmetry. Now, the other way that I could have known before I started that this graph was going to open down is because this a value is negative. If the a value is negative, that reflects the parabola over the x-axis, so it would make it open down. Now, the last thing that we'll do is talk about domain and range in interval notation. So remember interval notation for domain and range. Domain, we look at all the x values that we can have. So we go left to right on our ordering. So the leftmost x value that we can have way out here is actually negative infinity. Okay, well, you might be thinking, well, doesn't it kind of stop right there? And the answer is no. I can keep moving to the left out here, and I'll eventually get to a point on the parabola. It's going to take a really, really long time, but eventually you'll do it. So the domain here is negative infinity to positive infinity. And for my range, okay, remember range, we always go floor to ceiling on the y values. We go floor to ceiling on the y values. So the floor, because it opens down, is negative infinity. And the ceiling is up here. It's going to be the y value of the vertex, which in this case is 2. And we use a bracket on the 2 because we can actually equal 2. It's in the realm of possibilities for us. Okay? So that's all the attributes that you need to know about vertex form. Okay, so let's try another one. Okay, here's example 2. Now what I would do is I'd pause the video now, and I would try to do example 2 and all of its attributes by yourself. Okay, when you're done, start the video back up again, and I will talk you through all of the attributes. Okay, welcome back. Hopefully you took me up on my advice to pause it and try this on your own. Okay, best way to learn math is just to do it. Okay, so I'm going to go through this. My vertex here should have been at negative 1.5, negative 2.5. Remember, I'm just taking my h and my k values. Don't trust the sign on h, trust the sign on k. So if I know my vertex, my axis of symmetry here is going to be x equals negative 1.5. It always matches the x value in the vertex. My y-intercept is the only part of this that I actually have to do real work on, okay? I'm going to take 0 and plug it in for x. So we're going to find f of 0. So that's 0.25 times 0 plus 1.5 squared minus 2.5. And I'm going to clean that up. So I get 0.25 times 2.25 minus 2.5. And I'm going to go ahead and trust a calculator to help me with some of this work here. Okay, so I'm pretty sure that when I do this here, let's go ahead and go to the Desmos calculator here. So that was, we said 0.25 times 2.25 minus, what was it? Minus 2.5, okay? Minus 2.5, that gives me negative 1.9375, okay? Negative 1.9375 is my y-intercept. Okay, Now, if I draw a sketch of this graph, okay, it doesn't have to be perfect. We're just drawing a rough sketch here. You don't even have to use graph paper. I start with my axis of symmetry is at negative 1.5. My vertex is down here in quadrant 3, negative 1.5, negative 2.5. My y-intercept is somewhere over here, okay? I'm going to reflect that over the axis of symmetry so that it looks nice and symmetrical. And then I'm going to draw a sketch of my parabola. Now, when you do that, identifying the domain and range should be pretty easy for us. The domain is negative infinity to positive infinity. And the range, remember the range, we go from floor to ceiling. So my floor here is negative 2.5, and my ceiling is infinity. Okay? So those two problems where you pull out, you derive some of the key attributes from vertex form. The last thing that I'm going to show you in this video is how to write a possible quadratic function in vertex form when they give you some of the attributes. So we're going to kind of work backwards here, okay? So take a second, read this to yourself, and then we'll work on it together. It says, write a possible quadratic function in vertex form that has a vertex at negative 2, negative 4, and passes through the point 4, negative 22, okay? So the first thing that you probably want to remember is, what does vertex form look like, okay? And I always start by writing this out so I can kind of have an idea of what I'm looking for, okay? Now, the whole beautiful part about vertex form is the vertex tells us the h value and the k value. So I can right now, I can take this h value and plug it in for h, and I can take the k value and plug that in for k. So let's rewrite this and replace h and k. So I have f of x equals a times x minus 2 or x plus 2. You're right, it's x plus 2. And then minus 4 or plus 4. Right, again, it's minus 4. And hey, just so you know, there's no shame in saying the answers out loud. You're probably alone in your house or your room right now. It's no problem. Nobody's going to know. I'm talking to myself right now. It's not weird. Okay, so now the next thing that you're going to do to find a, okay, and I want to make a point to a lot of you. You are not finding slope. You are not finding slope. When we did absolute value graphs at this stage, you found the slope, and that's not how we're going to approach a quadratic. Quadratic functions are curved. You can't use the linear slope formula that you want to use. You can't use that on a curved line, okay? So what are we going to do? Okay, what are we going to do? We're going to use the second point that's given, 4, negative 22. So what I mean by that is we're going to set this function equal to negative 22, and we're going to plug 4 in for x. So we get negative 22 equals a times 4 plus 2 squared minus 4. So the rest is kind of simple algebra. You're going to add 4 to both sides, and you get negative 18 equals a times 4 plus 2 is 6. 6 squared is 36. Divide both sides by 36, and you get a equals negative 1/2. So now the last thing that you have to do is you have to put it all together in your equation. F of x equals negative 1/2 times x plus 2 squared minus 4. And that is your final answer. Okay? So that's a pretty quick overview of vertex form and quadratics. Come back for the next video where we go over standard form. Y'all have a good night.